Welcome to Arizona State University's University Academic Success Programs. This video will cover the topic partial derivatives.
What is the difference between a partial derivative and a total derivative?
In the case of a total derivative, the function involves only one variable and we take the derivative of the function with respect to that variable. However, in the case of a partial derivative, the function involves more than one variable and we take the derivative of the function with respect to any or all of these variables. We represent the total derivative using d by dx. Thus, for a function f, we represent the total derivative of the function as df by dx. It is important to note that in function f, the only variable involved is x. We represent the partial derivative using dou by dou x. Hence, partial derivative of a function g can be written as dou g by dou x, where g is a function composed of three variables x, y, and z.
Okay, I know how to take the total derivative of the function, but how do we take the partial derivative of the function?
While taking the partial derivative of a function, we take the derivative of the function with respect to the given variable and treat other variables in the function as constants. Let us consider an example. Let us say we have the following function f equals 5x square y cube plus 2x square z, and we are required to evaluate the partial derivative of the function f with respect to the variable x.
There are three variables, x, y, and z, right?
Yes, there are three variables x, y, and z in the function f, and we are required to evaluate dou f by dou x. We have dou by dou x of 5x square y cube plus 2x square z. As we already know, just like the total derivative, we can apply the distributive law to the partial derivative as well. Thus, we can rewrite the above expression as dou by dou x of 5x square y cube plus dou by dou x of 2x square z. Let us evaluate the partial derivative for each term and then finally determine the sum. The first term is dou by dou x of 5x square y cube. While taking the partial derivative of this expression with respect to x, we treat the other variables, y in this case, as constant and perform the normal differentiation. Dou by dou x of 5x square y cube equals 5y cube times 2x, which equals 10xy cube. Similarly, let us evaluate the partial derivative of the second term with respect to x. The second term is 2x square z. We treat the variable z as a constant while evaluating the partial derivative of 2x square z with respect to x. Thus, dou by dou x of 2x square z equals 2z times 2x, which equals 4xz. To obtain the partial derivative of the function with respect to x, we can sum the partial derivatives of the two terms we have obtained above. Dou f by dou x equals 10xy cube plus 4xz, which equals 2x times 5y cube plus 2z. We can have functions involving product of algebraic and trigonometric functions, but the technique is the same in all the cases.
Okay, I think I understand the concept. While determining the partial derivatives of a function with respect to a variable, we treat all other variables in that function as a constant and determine the derivative.
Perfect.